So now, the third method of solving systems of linear equations. Some people call this the addition method. Some people call it the elimination method. Let's look at an example. Here's a system of equations. We would like to solve it. We could solve it by the substitution method. That would involve starting by taking one of those equations and getting it solved for either x or y. Trouble is, with this particular system of equations, there's no really easy way to do that. We can do it, but not without introducing fractions. Like, we could take the top equation and solve it for x, subtract 3y from both sides, so 2x equals 18 minus 3y. Then divide both sides by 2, and we get x equals 9 minus 3/2 y. Then substitute into that other equation 5 times 9 minus 3/2 y minus 3y equals 3. And take it from there, and it would work, but we would be working with fractions. It would get a little bit complicated. There's an easier way in this particular example. So here's the easier way to do this. We take these two equations and we essentially add them together. 2x plus 5x adds up to 7x, plus 3y and minus 3y just add up to 0. They cancel each other out. And over on the other side of the equal signs, 18 and 3 add up to 21. So now we have the equation 7x equals 21. Oh, that's easy. We can divide both sides by 7 and get x equals 3. So that's half of the answer. We have our number for x. What about y? Well, take 3 and stick it in place of x in either one of the equations we started with. If I use the first one, we have 2 times 3 plus 3y equals 18. So that means 6 plus 3y equals 18. Then subtract 6 on both sides, 3y equals 12. Divide both sides by 3, y equals 4. And now we have our solution. X is 3 and y is 4. If you want to check, that does work in both of these equations. 2 times 3 plus 3 times 4 would be 6 plus 12, which would be 18. And 5 times 3 minus 3 times 4 would be 15 minus 12, which would equal 3. Okay, now looking at this, first time you see something like this, there's a couple questions you might have. One thing you might wonder about is, well, are we really allowed to add equations together like this? Why is this legal? Well, we are allowed to add the same number to both sides of an equation. We do that all the time when we're solving equations. You can add the same thing to both sides. Well, that's really what we were doing here, because we added 5x minus 3y to the left side of the top equation, and we added 3 to the right side of the top equation, but the second equation said that those two things are equal to one another. 5x minus 3y and 3 are equal. They're the same number. So we really added the same thing to both sides of that top equation. The other thing you might wonder about is, why did this work? Why did it help to add two equations together? Well, it helped because we had a plus 3y in one equation and a minus 3y in the other. And when we added those together, that eliminated the y's. Those were opposites of one another, so they added up to 0, and that got the y's completely out of the picture, and we could focus on the x's. So let's look at another example. Here, the two equations that make up our system are negative x plus 10y equals 3 and 5x minus 11y equals 24. Now here, if we just go ahead and add these two equations together, the negative x plus 5x gives us 4x. The plus 10y minus 11y gives us minus y. The 3 plus 24 gives us 27. And that didn't really help us all that much. We just got another equation that still had both an x and a y in it. We aren't really any closer to figuring out what either one of those variables has to be equal to. And the reason that didn't help us is because we didn't get to eliminate either of the variables. But what we can do is take that top equation and notice there's a minus x in that top equation and there's a 5x in the bottom equation. I'm thinking to myself, gee, I sure wish there was a minus 5x in that top equation, because then when I added the equations together, the minus 5x and the positive 5x would add up to 0, and that would eliminate x's. I sure wish there was a negative 5x here. How could I get that to happen? Well, I am allowed to take an equation and multiply both sides by the same number. So let me take that top equation and multiply everything on both sides by 5. When I do that, the result is that I have negative 5x plus 50y equals 15. The bottom equation is fine the way it is. I'm just sliding it over. 5x minus 11y equals 24. And now, when I add these two equations together, the x's do get eliminated because the negative 5x and the positive 5x add up to 0. Meanwhile, the plus 50y and the minus 11y add up to 39y. And over here, the 15 and the 24, when I add those together, I get 39. So look, 39y equals 39. I can solve that. Just divide both sides by 39. So y equals 39 divided by 39 is 1. And now take that 1 and stick it in place of y in, I could use either equation, but I'm using the top one. Negative x plus 10 times 1 equals 3. That just means negative x plus 10 equals 3. Subtract 10 on both sides. Negative x equals negative 7. Go from negative x to just x by dividing both sides by negative 1. And we have x equals 7. So there's our solution. X is 7 and y is, oops, that's not what I said. There, x is 7 and y is 1. And that makes both equations true. Okay, let's try another example. I need to, in order to eliminate one of the variables, either the x's or the y's, I need the coefficients in front of that variable to add up to 0 so that they can kill each other off. That means they have to be the same number except that one of them has to be positive and the other one has to be negative. Can you see how we can accomplish that? Well, at least one way of doing that is I could multiply the top equation by 2. That would turn this 3x into a 6x. Can you see what I'm going to do to the bottom equation then? I need a negative 6x down here to go with the positive 6x up here, so I'm going to multiply the bottom equation by negative 3. So when I do that, here's what I get. The top equation gets multiplied by 2. Don't forget that everything on both sides, it all has to get multiplied by that same number. So 6x minus 16y equals 14. And then the bottom equation, when I multiply everything on both sides by negative 3, I get negative 6x plus positive 15y equals negative 15. Now the x terms are all set up to kill each other off, so I'm going to go ahead and add these equations together. And I get negative y equals negative 1. The 6x and the negative 6x just add up to 0. the negative 16y plus positive 15y add up to negative 1y, or just negative y, and the 14 and the negative 15 add up to negative 1. So we got negative y equals negative 1. We want plain old y, so divide both sides by negative 1, we get y equal to positive 1. And then take that 1 and go back and plug it in for y into either one of these equations will work. If I use the top one, 3x minus 8 times 1 equals 7. Well, 8 times 1 would just be 8, so 3x minus 8 equals 7. Add 8 to both sides, 3x equals 15. Divide both sides by 3, x equals 5. So we have our solution. X is 5 and y is 1. Now that we've seen some examples, let's stop and take a look at how this works in general. Here's the procedure to follow for solving by the addition method, or the elimination method, if you want to call it that. First, both of the equations have to be lined up the same way. The x terms in the same place, the y terms in the same place, the constant terms in the same place. So if it's not already that way, you might need to do some rearranging, add or subtract the same thing on both sides so that they are both lined up the same way. Then multiply both sides of one or both of the equations by whatever it takes so that the coefficients on one of the variables, either the x's or the y's, are opposites of one another. Then add the equations together. If you've set things up correctly, you should be able to eliminate one of the variables, and you end up with an equation with only the other variable left. So then go ahead and solve to find what that variable has to equal. You get a number for whatever that variable is, and you take that number and you substitute it back into either one of the original equations and solve to find the other variable. So now you've got both variables, you've got your solution. Now, if you get a contradiction when solving, like if you add the two equations together and both variables get eliminated, so you just have something like 0 equals 12 or something that is just plain not true, that shows you that your system that you're trying to solve is inconsistent. It has no solution. The two equations would represent lines that never cross. And the other thing that could happen is that both the variables get eliminated, but you get something that is true, like 0 equals 0, an identity. And if that happens, that means your system is dependent. It has infinitely many solutions because the two equations are equivalent to one another. So anything that works in one of them is going to work in the other one as well. They represent the same line. So now that we see how this works, I'm going to end this video here, and then I'm going to come back in a second video and we'll work through a few more examples so we really get the hang of how this works.